Question 1. What is the structural difference between a 3-layer DIAC and a 5-layer DIAC? While a 3-layer DIAC resembles an open-base transistor, a 5-layer DIAC is structured like two inverse parallel silicon-controlled rectifiers sharing a common gate region. Question 2. What parameter describes the difference between the positive and negative breakover voltage values of a DIAC? Breakover symmetry, or delta VBO, measures the absolute voltage difference between positive and negative breakdown limits. This is typically controlled to within 3 to 4 volts. Question 3. What is the term for the significant voltage drop across a DIAC that occurs immediately after it enters the conduction state? Once breakover is reached, the voltage across the device falls sharply by several volts. This drop is formally called the breakover voltage fallback, or delta V. Question 4. Why is a large voltage fallback delta V highly desirable when a DIAC is used to trigger a TRIAC? A high-voltage fallback allows the trigger capacitor to discharge a powerful, high-amperage current pulse directly into the TRIAC gate, ensuring fast, clean turn-on. Question 5. What specialized bidirectional high-voltage switch operates similarly to a DIAC but latches into a virtual short circuit with very low on-state voltage? A SiDAC, or silicon diode for alternating current, is a high-voltage trigger device that conducts like a DIAC but latches into a near-complete short circuit with low on-state voltage drop. Question 6. Around what typical baseline voltage range do commercial DIACs undergo breakover triggering? Unlike low-voltage DIACs which trigger around 30 volts, DIACs are designed for high-energy mains applications, typically breaking over between 100 and 300 volts. Question 7. How does an increase in operating temperature affect the breakover voltage threshold of a standard DIAC? DIACs have a negative temperature coefficient. As temperature increases, carrier generation rises, causing the device to reach breakover at a slightly lower voltage. Question 8. What application uses a DIAC to generate high-voltage starter pulses to ignite metal halide or sodium lamps? In gas discharge lamp ballasts, a DIAC is used to discharge a capacitor through a step-up pulse transformer, generating the kilovolt spikes needed to ignite the gas. Question 9. What safety parameter specifies the peak pulse current a small DIAC package can handle during capacitor discharges? Though physically small, DIACs must handle repetitive peak currents of several amperes for microsecond intervals during capacitor discharges, defined by the ITRM rating. Question 10. What dynamic issue can cause a DIAC to undergo false breakover without exceeding its rated V_BO value? Rapidly rising off-state voltage transients inject displacement current through the device's internal capacitance, falsely triggering breakover below its static rating.